Assalamualaikum and good morning. My name is Muhamad Hazim bin Abdul Rahman, and today I am going to present to you about Lab 10 for Mechanical Engineering Lab 2, which the title is Thermal Expansion Experiment. So without further ado, let's start. The objective of doing this experiment is to determine the volume expansion of solids using the dilutometer. Okay, based on the experiment, the result that we obtain is as shown in the slide. Okay, initially the temperature that we set is 34.2 degrees Celsius, which is equivalent to 307.2 Kelvin, and the change in length of the measuring tube for aluminium, brass and copper at the initial temperature is 0 for all of them. Okay, when the experiment began, we can see that there is the increase in change in length of the measuring tube. Okay, so when the final temperature that we set, which is 75 degrees Celsius, and the change in length measurement is taken, we can see that there is a difference of the value of the change in length at the temperature of 75 compared to the initial temperature, which is 34.2. Okay, so here we can see that the highest change in length is for aluminium, which is 0.56 millimeter, followed by the brass 0.45 millimeter, and lastly the lowest is for copper, which is 0.40 millimeter. Okay, so based on the tabulated data, we can now calculate the coefficient of linear expansion. Okay, by using the equation as shown in the slide, which is alpha equals to delta at L over L naught times delta T. The theoretical value that we get from the experiment is for aluminium is 2.20 times 10 to the power of negative 3, brass 1.8 times 10 to the power of negative 3, copper 1.6 times 10 to the power of negative 3, while for experimental 2.05 times 10 to the power of negative 3, 1.75 times 10 to the power of negative 3, and 1.56 times 10 to the power of negative 3. So by using the tabulated data, we then plot the graph of change in length versus temperature, and here we can see that the steepest line is from aluminium, followed by the brass and copper. Okay, so we can conclude that the highest change in length is for aluminium. So how to relate the experimental work with the engineering applications? So thermal expansion is an important consideration for engineering because different materials exhibit changes in size when exposed to heat, thus affecting the length, width, surface area, and also volume. So for example, we can find the real life application of thermal expansion at railway tracks and steel bridge. Space is left between railway tracks and as an allowance for the expansion when temperature increase, otherwise the rails may buckle. Similarly, long steel bridge are designed to include expansion joints to allow for their expansion by fixing one end and resting the other end on rollers. So that's all from me. Thank you.